Hello viewers, in today's class we are going to discuss one important integral based on Dirac delta function, right? And here we have to evaluate this integral from minus infinity to infinity x cos square x delta of square root of x minus square root of pi dx, right? So here delta is the Dirac delta function. So viewers, in our earlier videos, we have already solved some examples on integration based on Dirac delta function, right? So in this lecture, we'll solve this integral and we'll see one important property of Dirac delta function which will be used to evaluate this integral, right? So let us call this integral as I. So now see here we have the function delta of square root of x minus square root of pi, right? And in this problem our prime aim is to simplify this delta function, right? So here we'll use one important property of Dirac delta function which says that delta of square root of x minus square root of a is equal to 2 times square root of a and delta of x minus a, right? So this is an important result in Dirac delta function. So this is an important property of Dirac delta function, and we'll use this property to simplify this integral, right? So here we have delta of square root of x minus square root of pi. So if we compare square root of x minus square root of pi with this one, then we can see that a is equal to pi, right? So according to this property, delta of square root of x minus square root of pi is 2 times square root of pi, and here we have delta of x minus pi, right? So now this integral I can be written with the help of this property, that is minus infinity to infinity, and here we have x cos square x, and for this term we have 2 root pi, and here we have delta of x minus pi and dx, right? Now 2 root pi is a constant, so we can take it outside the integral sign. So we have 2 root pi and we have minus infinity to infinity x cos square x and delta of x minus pi dx, right? So now we have this integral, right? And if we compare this integral with this one, that is minus infinity to infinity f of x delta of x minus a dx, then the value of this integral is equal to f of a, right? Because see here we have delta of x minus a, and this point x is equal to a, it acts on this function, or in other words we can say that the delta function acts on this function f of x at this point x is equal to a. So the value of this integral is equal to the value of the function at this point x is equal to a, right? So here we have a is equal to pi, and this is f of x, right? So our f of x is x cos square x. So the value of this integral is 2 root pi, and we have here x cos square x, and we'll evaluate this expression at x is equal to pi. So now we have 2 root pi, and here we have pi. For x will take pi, and we have cos square of pi, right? and we know that cos pi is cos 180 degrees, that is equal to minus 1. So cos square pi is equal to minus 1 square. So this quantity becomes positive. So I is 2 times pi raised to half. This is square root of pi, and here we have power 1. So these two powers get added. So we have 2 times pi raised to 3 over 2. So the value of this integral is equal to 2 times pi raised to 3 over 2, right? So viewers, in the next video, we'll see how to prove these type of properties based on Dirac delta function.